everybody, Mrs. Buckley here, but you knew that. Today we're going to talk about creating meaningful tables of values. Now we've created lots of tables of values in the past. For instance, I could give you some random equation like this. Nice, easy one. And remember, I always asked you to use -2, -1, 0, 1, and 2, because that would center your graph around the origin. These numbers don't always make sense when we're talking about a word problem, and I'll show you what I mean. Let's start by looking at this problem that we worked on earlier in the week. We wrote this equation together. We said that a tree is 3 feet tall. It grows 1.5 feet every year. We used H for height and Y for years. So we said that the height would be equal to the 3 that it started with plus 1.5 feet for every year it lives. Let's make a table of values for this, and this is what you're doing with me. So please copy down that equation. And let's do years and height. So can we have -2 years? No, of course not. That would be time travel. We cannot go back in time. Can't have -1. Could we have 0 years? That's kind of a weird concept. But in math, let me scooch this up a little. In math, 0 years means now. So let's write this in. Let's write the word now next to 0 years. And right now, the tree is 3 feet tall. So 0,3 is the first meaningful entry, pair of values that we can include in our table of values. Certainly there can be 1 year going by, 2 years going by, and 3 years going by. I think if you go up through 3, 0 through 3, you're going to be all set. So if at 0 years it starts at 3, each year it is going up by 1.5 feet. That is our rate of change. And because it is a positive rate of change, this means that we are adding 1.5 every time. So 3 plus 1.5 is 4.5. So at the end of the year, the tree is now 4.5 feet tall. And same thing, each time we add 1.5 so that the rate of change appears here in our table of values. And it appears here in our equation. So we started at 3, we added 1.5. If we add 1.5 again, we end up at 6. And if we add 1.5 again, we'll end up at 7.5. So this table right here is a meaningful table of values because it's not saying anything about negative time or negative years or anything like that. This table makes sense based on the actual word problem and the equation. So there's our first one. Let's take a look at number 2. And again, this is one we did earlier in the week. So a tree has 500 apples. Each batch of applesauce requires 25 apples. Use A for apples on the tree and B for batches of applesauce. So here's our equation. The number of apples on the tree, A, equals the 500 that are on there right now, minus 25 per batch of applesauce. Now, I want to box in this subtraction here to emphasize that this is a negative rate of change. A negative rate of change. And let me start with my table of values. So let's see, we are going to start out with batches of applesauce versus apples left on the tree. I definitely cannot make negative numbers of batches of applesauce, but I could make 0 batches of applesauce. And remember, in math, times 0 refers to now. And right now, that tree has 500 apples. So I can make a batch of applesauce, or 2, or 3, and I could keep going. So because the rate of change is a negative rate of change, right? It is 25 apples being removed from the tree. I am subtracting 25 each time. So after one batch, I don't have the 500 anymore. I have 500 minus 25, or 475. Same thing here. The rate of change is minus 25, minus 25, minus 25. We see it here in the problem, we see it here in the equation, and we see it on this column in our table of values. So after 2 batches, there are 450 apples on the tree, and after 3 batches, there are 425. Now, when there are no apples left on the tree, this table would have to end because there's no such thing as negative apples. So this table of values has a definite beginning and a definite end in order to be meaningful, right? We could keep going and going and going and going with batches of applesauce till there are no apples left on the tree. But we could not go farther than that. All right, let's take a look at number 3 here. And again, this is one we did before. A babysitter charges $10 for art supplies and $12 per hour. Use C for total charge and H for hours. So let's do hours and charge. No such thing as negative time. I cannot use -2, -1. Could there be 0 hours? Well, let's think about that for a second. Let's say the babysitter shows up at your door, hands you the art supplies, and starts babysitting. Before this babysitter has even started, before 0 hours have been worked, meaning now this babysitter is on your doorstep, you have been charged $10 for the supplies. So the rate of change is right here in the word problem, $12 per hour. It is right here in our equation. And the rate of change is right here in the table. So after 1 hour, we owe for the art supplies and the first hour of babysitting. So the total charge is 22. And with this rate of change of 12, that means we're just adding 12 each time. So 34 and then 46. So this is the meaningful table of values for number 3. Okay, we're going to do one more together, and then I will give you the independent ones. Right? Not too bad. Not too bad today. And let's see what I've got here. Okay, so a large pizza is $15. Each topping is $2. Use C for total cost of the pizza and T for number of toppings. So we are going to do toppings and the total cost. Certainly can't have negative toppings. We could just choose plain cheese and have 0 toppings. That would be $15. We could have 1 topping. That would be up to $17. We could have 2 toppings and 3 toppings and so on until we run out of toppings. And because the rate of change, wait, where's my equation? There it is. Because the rate of change is a positive 2, that means that we're adding 2 each time. So that's 19 and that's 21. Now, sometimes making these tables can seem very obvious and you can do it without thinking, but we're going to be talking more about rate of change, which turns out to be the slope of an equation, of the line of the equation. So I want you to be mindfully creating these tables of values and not just plugging in the numbers and writing them down. Okay, so I'm looking for some solid thinking on these independent ones. So 5, 6, and 7 you're doing on your own. And you're going to do great with this. Thanks for your attention. Happy day.